Hello, everyone. Welcome to Rational Science, the only site on the internet that does physics. We do physics right. Everybody else does what? Mathemagics, as we call it. They move concepts around. We are the only site that moves physical objects. Okay? That's how we do science. That's how we do physics. And we're going to start with one of the branches of science, which is physics. And within physics, there's you could say a branch, specialty, right, known as paleontology. And within that, we have extinction. So we deal with extinction under physics. Okay, it's one of the branches out there that involves physicality, and that's why we deal with it. The other reason I deal with extinction, just for your knowledge, is that relativists, the mathematicians in general, they believe we're going to live forever. That's what they fed Hollywood, and that's what Hollywood fed the masses. So everybody believes that we're going to live forever, and that there's no problem that man cannot fix, right? And so because of that, everybody's got this notion that nothing imminent is about to happen, and so they're being blindsided, as far as I'm concerned, to what's really going on and what's going to be happening very soon. Okay, within our lifetimes, almost guaranteed. Okay, so let's get started with the extinction part, and I'm going to do some news headlines that caught my eye this week related to that, and some of the things that are going on in the world. The evolution of society, evolution of our economics, evolution of our military and politics, right? Okay, and here's one of the things that came up. It was these Taliban. As you know, they took over the government in Afghanistan. It's now known as Taliban. And they said, yeah, women can study, but they have to study separate from men. No, segregation. We have segregation in the schools over there, okay? And they believe that women should study certain things that are authorized by Islam, okay? According to them, their reading of their scriptures, right? And I suppose these are the subject matters that the girls are going to be looking at in college, babysitting, midwifing, cooking, sewing. Is that what they're going to be studying? Because the article says that this comes from the Taliban, okay? This is what they say. This is the answer they gave. They said, women should give birth and raise children. That's their job, okay? They should be limited to that and nothing else, okay? Well, I'm sure a lot of women are struggling to get to Taliban land, to Kabul. Please don't crowd the airplanes, girls, okay? There's room enough for all of you, okay? So what I did as a result of that, when I saw that, that notion that the Taliban have, that women should only give birth and raise children, that's their job, that's their only function in life, I ordered a Taliban dictionary, okay? And I received it this very morning, from Kabul, directly from Kabul. And I looked up the word woman. I mean, what does the word woman mean to the Taliban? Okay, and I found an answer. I found it in their dictionary. It says woman, a womb, uterus, procreator. Okay, so now I understand why they have that. Women should only give birth and raise children. Okay, so now you know where that comes from. And there's a fellow who, in fact, seems to agree with them. And he put a note, and this goes like this. He says, "I didn't say ask women if they'll give up their privileges willingly. Of course they won't. I said take their privileges away from them," meaning totally disregard for what they want. I'm not sure too many women will agree with him, But what I can say is that, I think he found his calling. He should probably travel to Afghanistan and become a Taliban. What do you think? I mean, let me know. I think he's not part of this part of the world. He should, maybe join the Taliban. Okay, that would probably be his calling. Okay, another thing in the news related to extinction, in this case, population. As I've been arguing, population will increase at a slower rate as time goes by from now on. We have no chance of increasing the rate of growth of population, meaning we can't increase demand, coupled with the fact that we're in a service economy. I think those two things are seal our fate. Okay, and so here in the news we have one case, Mr. Putin. He says Russia seeks to stimulate the birth rate. Says President Vladimir Putin has announced a series of plans to increase the number of children being born in Russia from an average birth rate of under 1.5 per woman to 1.7 within 4 years. Very ambitious plan. Okay, on Wednesday he told Parliament, his Parliament, right, the Duma, the birth rate is falling again. Yeah, all these legislators will do something about it before pledging state funding for new mothers. And and they've been doing this because this news is from January 2020, but there was another one now in August, and they've been putting out this kind of news for Russia for the last 5, 6 years at least, maybe more. I've seen several articles talking about the dire problem that Russia has, that its population is not increasing. And some people always tell me, well, we should cover the land, and or they tell me that the world is crowded, and it turns out Russia is an empty country. All the people are in big cities. The 5, 6 cities Russia has, big cities. That's it. On the other side of the Urals, it's completely empty. It's just bare land. Not completely bare. I mean, it's got trees and everything, but I mean, it's underdeveloped land. And if nobody goes there and builds a new town, we're not going to have more population in Russia. And the same can be said for Australia, Argentina, primarily those empty countries, Algeria. They're big countries that are not creating new cities. They're not colonizing the land, okay? And so all I can suggest to him is that there is a solution to his problem, and it came from a bit of news that I found somewhere else, and it looks like this. And it says that Polis, first openly gay governor elected, marries in Colorado. And I said, okay, looked down to the article, and I found this note at the bottom. It says, talking about his sweetheart, right? He says, they have been together for 18 years and have 2 children, a 7-year-old boy and a 9-year-old girl. Now, I'm sure Putin could learn from these people. I mean, instead of persecuting, LGBT, XYZs, and so on, why doesn't he encourage them to have children like these 2 fellows did? Okay, if that happens, I'm sure the rate would increase in Russia, and they could populate, the other side of the Urals completely. So, maybe he just should take some pointers from these 2 fellows. Okay. Anyways, here we have a statistic, okay? It says where women are having the most children on the planet. And you can see the countries that are mentioned there. They're not the biggest countries population-wise in the world. But what they all have in common is that most of their land is, or most of the people in their land are agriculturalists. They're still in the farms. They're still out there in the wilderness. And so what is my argument? My argument, again, I want people to quote me right because they always misquote me. My argument is that population stops when people come to the cities. It's got nothing to do with the efforts that non-governmental organizations, NGOs, do out there, all this work. I mean, that helps. One child per family, China, that helps. But the real problem is when people come to the cities. You can't have children in the cities. Cities is not a place. A city is not a place to raise children, and people have other things on their mind than having children. Among them, staying alive one more day. They can barely reach the end of the month. They're not going to have 10 children like our great grandfathers had, hundreds of years ago. So the issue is that as long as and this gives you an idea because these are all agriculturalist countries still. They're backward countries in the sense that people still have not come to the cities. You don't have big, great cities in these countries except maybe one or two. The rest of the country is barren, and that's where most of the people live. And so as long as people live in the country, they will have children. When they come to the city, I don't care if they're poor, I don't care if they're black, I don't care if the women are old or young, they will not have children. Okay, so it's got nothing to do with, I can't say it doesn't have to do with money because money does play a part in it. But the main ingredient is going from the country to the city. It's that transition that stops population growth. Okay, that's my argument. Whether you accept it or not, that is my argument, so don't misquote me. Okay, and so here, it doesn't matter what these few countries do. You can see the rate has been dropping steadily since 1963, and there is no end in sight, and it will continue to drop. That's the growth rate for the entire population on Earth. That means that it doesn't matter what a few countries in Africa especially do, they will not be able to reverse that trend. Okay? That trend is fixed, guaranteed, can't change, and I even say that the drop is going to be sooner because extinction is going to occur before 2050. That's my take on that. Okay, so I don't think we're going to make it to 2050 zero population growth. Zero population growth is going to occur much, much sooner. Okay, here's another bit of news, concerns extinction. This one you should really keep in mind. Okay, several headlines here. One from the Examiner. The world is a jungle. France fumes at U.S.-Australian nuclear submarine deal. Okay, they made a deal there, military stuff. Okay, they sold some submarines to Australia, and because of that, Australia's not buying some hardware from France. So the French are upset. Okay, and then China also is not very happy with that. It's a Cold War mentality. China slams new U.S. pact with UK and Australia. Okay, and then just to add to that, first we have Afghanistan. The Americans left, right? American government decided to leave Afghanistan like it left Vietnam, right? And it pulled some missiles out of Saudi Arabia and Yemen. And so the issue is whether there's a shifting of U.S. resources, military resources, from the Middle East and Europe to the east, to the total east. Is China a more important adversary or a problem for the United States than the Middle East? So, you only have so many resources, and you got to find out how you're going to allocate those resources. And I think what you're seeing today, maybe it's been happening for some time, but now they're taking some of these major moves. They're moving the pawns on the chessboard, okay? And I think the decision has been made to make a strategic move, and that is use more resources in the East than you do in the Middle East and even in Europe. It's like we have Europe in our back pocket. We have the Middle East, those countries that are still loyal to the United States, that's in the back pocket as well. They're not going to go anywhere. They're not probably going to switch sides at least so easily, Maybe they can control that through diplomatic means. And meanwhile, shift the hardware to the East for the rising sun, okay? That's what I think is happening. Okay, just a bit of news for you there to ponder. Another bit of news, and this is an interesting one. Okay, it affects a lot of people today. 7 ways men live without working in America. Saying that since 1950 to today, 70 years now, the the number of men who work within working age uh, that work has been dropping. And today it was in the 80s, 80 something, 85, I think it was. And today it's barely 66, 67% of working age men that are actually working. All the rest are stay at home dads or brothers or sons or whatever. Okay. And these are the reasons the article says that men are staying at home. Okay. Unemployment insurance. Okay. You can include, Social Security with that. I'm sorry, I mean welfare. Okay. Early retirement, pensions, disability, and lawsuits. Okay, savings, trading stocks, and Bitcoin. If you can do Bitcoin and you're doing okay, why are you going to get a job? Working for cash. Under the table, black market. Okay, living off family members. Okay, lots of people doing that. Illegal work. Primarily drugs. Okay, selling drugs and living off the land. The guy says, I'm sick of society. I'm going to go to the woods, do some fishing, hunting, carry my gun, and live, like a real man should live. Okay, so those are some of the things that are happening out there. And what is interesting, the rate of women who work has gone up, while those of men have gone down. So men are staying at home, again, with brothers, with parents, with whoever, okay, sometimes alone. And women are going out there and getting jobs. And what the men are doing is living off the fat of the land, so to speak. They find ways of living without having to work. Okay, interesting trend. Okay, the question is whether that trend can continue. It's for you to ponder. Okay, we have Mr. Trump here. Another bit of news. He says, predicts America will end within 3 years. Just the amount of time that I guess Mr. Biden has as president. So he says America will come to a dead stop in 3 years. And then he says the former president also hinted to Newsmax host Sean Spicer that he may run for the presidency in 2024. Now, why would anyone who thinks that America's coming to an end in 3 years look for a job as the president? There seems to be a contradiction there, in my mind at least. Okay, and I don't have anything against Mr. Trump. I want you to know that. I'm just asking a question. I'm saying, why would he say the world is going to end in 3 years, or the United States? For me, it's the world, because if the United States ends, it's the end for the world. But why would he want to be president if the United States comes to a dead stop? Which exactly, he didn't specify what he meant by that, but I'm assuming he means that, economically it's going to come to a dead stop, and by inference, China is going to pass the United States. That's, I guess, what's going through his mind. And, again, if the United States comes to a dead stop, I think it's the end of the world, not the end of America. Okay, so we have to bolster the United States any way we can, whether you like it or not, whether you love the United States government or not, irrelevant. We have to help the United States government stay afloat, because if it collapses, we're all in trouble. That's my argument. Okay, that's my pitch to you. Okay, one fellow says, hey, don't worry about it. He says, the United States will recover, or the economy, the global economy will recover. He says, I disagree that it will be a complete downfall after America. It will slow down trade and therefore slow down food across the globe. But he feels that it's going to somehow come back on its feet. It's just going to be a dip, another depression, another recession, whatever you want to call it. I think that if there is a collapse, I call it extinction, not depression. Okay, but again, that's me. All I can say is that I cannot imagine us recovering from the next major collapse. Okay, another fellow has a different opinion. He says, I never said U.S. would become part of the Chinese empire. One thing I suggested the other day, that if the United States falls back, some people are maybe insinuating that the United States is going to be a province, a state of China, just one of the colonies out there, the small economies that pay tribute to the big empire, the new Rome. That's the insinuation, right? China is not part of a Western empire, okay? The West is doomed. Whoa. The Western nations are using the Great Reset. That's, I talked about it a little bit the other day. We have this fellow, Schwab, and he created this notion of the Great Reset, where essentially there's going to be a new world order in which money is not going to be a problem. In fact, he says something along the lines, I can't remember the exact words, that you're not going to have a penny, but you're going to be happy. So quite different than when I went to college. One professor said the first day of class is, in this class, we're going to define happiness as money. If you have money, you are happy. Economics professor. The Western nations are using the Great Reset and COVID to introduce incremental authoritarianism so they can default under debt and pivot to electronic money. They can then print without borrowing in modern monetary theory. Well, they can print money without Bitcoin. They've been printing money for as long as I can remember. Okay, so printing money is no big deal. Today, in fact, all you need to do is just put another zero in a computer and you got another billion, another trillion, in the loop. So creating money is no big deal. Okay? And they've been doing that. With electronic money, they will also be able to completely control what the population used that money for and tax every cent in true Marxist fashion. This is again comes from this fellow Schwab, for those of you who are not familiar with him, and he's talking about the Great Reset, okay? And so this fellow got that information from Mr. Schwab, right? They will ultimately fail as Marxism always fails at this time. Maybe billions will die fulfilling part of your theory, okay? It's not part of my entire theory is that the entire system will collapse and there will be no possibility, even the possibility of recovery, okay? When money is no more, meaning people lost faith in money, in God we don't trust anymore, we don't accept money. And at that point, government, the Illuminati, whoever you want up there, has no control. They don't even have control over the army. They don't have control of the government. They don't have control over anything because money is no more. Nobody will accept money. How do you compel without money? Okay, so if money disappears, compulsion disappears. And by compulsion, I don't mean, putting a gun to your head in that sense. I mean that, you go to work as a policeman, as a guardsman, whatever, only because they pay you and because you need to make a living. And so you're expecting a salary. But if you're not expecting a salary, why are you going to go to work? More than likely, you're going to use your gun for something else. Okay? They will ultimately fail, okay? And when that happens, sometime in the 2030s, okay, he's very optimistic, we will have our opportunity to create something new in government. Something new in government. I'm wondering what he's referring to. What kind of government do you plan to have if the economy collapses? And I mean, total collapse. I mean, Bitcoin is just a number in a computer. Even checking accounts or money in a computer. That's all they are. It's just all these are just numbers in there. That's it. It's all abstract. And even if it were real, if it were gold, something you exchange with your hands, okay, so what? If no one accepts your gold because it has no value, it's just a rock, piece of stone. And nobody wants that piece of stone anymore. He wants a piece of limestone or whatever. Then money is no more. Your gold is useless. Your diamond is useless. Your pearls, your Your Bitcoin, your dollar bills, your euros, all that's worthless. You go to the store, nobody wants it. You want to pay someone his salary in money and he doesn't accept it. Okay, and so the question is, can that happen? And a lot of people say, no, it can't happen. And so they confuse the word can with the word will. Okay, you got to distinguish between can and will. One of my papers, I had to state that because it's not so obvious to a lot of people. Can it happen? Sure, it can happen. In fact, I can do a little thought experiment and show you that it can happen. All the people in the world, all the rulers get together and they decide, no, not that COVID is going to go, no. They decide that money is no more. Everyone shuts down their own money. Everybody in each of the countries, they decide to eliminate money. Can they do that? Well, I'm saying they can because I'm saying that's something we have within our power. Okay? We have the ability to destroy money if we want to deliberately. Can we? We can. If we want to, we can. We can destroy money tomorrow. We can destroy all the computers tomorrow. And there's no more money. All this fake money, that's all this abstract money. So can we? Yes. We can. Will we? That's a separate question. So we should not confuse will with can. Okay? And that's important because if we can, then we can still fit extinction within that can scenario. Okay? If we can destroy humanity today without throwing the bombs. All we have to do is destroy money today deliberately by maybe killing all the computers any way you want. Okay? We can say money is no more. We all agree that money is no more. Yeah, we destroy the economy. So we can. Will we? That's a separate issue. Okay, so do not confuse can with will. Okay, so what was this fellow talking about? He's talking about this fellow. This fellow goes against the previous one, Carl Schwab. Please look up Ernst Wolf, he says. Okay, so I look him up, and he has this video in which he says, uncovering the corona narrative. And what does he say? Well, these are the main points that he's got there. This fellow, he talks against this New World Order, specifically all this COVID thing that's going on. Okay, so he's dead set against it. He says this is a hoax. It was prepared by the governments, pre-planned. Okay, this is what his argument is. Okay. Says we're dealing with a complete destruction of the global financial system, but we are also on the threshold of reshuffling of a global strategic order. Again, a lot of these people think that we're getting rid of one order and replacing it with some other kind of order. Okay, this is what's going through their minds. Well, everybody thinks in the same way. They're so sick and tired of the politicians. They say we got to get rid of all this, and so they say, okay, we get rid of this. What do we replace it with? And so, you have the communists and the capitalists. The capitalists say, well, we're going to be trading with our neighbors and we get government off our backs. Okay, they're the anarcho-capitalists. And the other guys, we'll call them the communists, for lack of a better word. We get rid of all the money and we all live happily ever after. I don't know how, maybe exchanging goods or whatever. Just everybody is happy if they could get government off their backs. And the question is, can we live without government? We're a social animal. We created government. Can we get rid of this big monster, this, what is it? This monster we created is running amok. I was thinking of, not Einstein. I was thinking of the other fellow. Can't remember his name now. But okay, it says big credit bubble ever in the world. Okay, we got a big credit bubble. Loans that need to be repaid can't be paid anymore. This guy's supposedly an expert in economics. He's a journalist who specializes in economics. Okay, says the system is beyond saving. Okay. The derivatives bubble, 700 trillion. I talked about that in the past, okay? And I got the same number somewhere. We don't know how much it is, but this is a ballpark figure, okay, 700 trillion. We are in the final phase of this financial system. We are witnessing the looting orgy by major investors. Okay, so he's saying that the reason this COVID was created so that they could do all this looting behind our backs. Okay, well, there's a lot of conspiracy in his language, and some of it is okay, some of it may not be, at least from my point of view. Uh, what I agree with him is that the system is collapsing. That we agree. Where we don't agree is that he believes that there is salvation at the end of the line, and one of the ways you do salvation is by opposing what these people are trying to do today. Okay? And a lot of people are in tune with that. They say, I'm not going to follow, I'm not going to get my vaccine, etc. And they protest against the government for forcing them to do something they don't want to do. And my only concern there with this COVID is turning this into a conspiracy, and no one has been able to answer that question. Even this fellow, he hasn't even raised it. None of them have raised it. And the issue is it possible that Cuba, which is an enemy of the United States, Iran, which is an enemy of the United States, and so on and so forth, that they all agreed in advance before this COVID came out? Did they all agree and say, let's do this conspiracy all together, all the governments on earth, we all agree that we're going to create this COVID, and we're going to tell our people, each one in his own country, right? Both enemies and friends, we're all going to agree to tell our populations, our respective populations, that there's this disease out there that's going to kill us, and so that's going to force them to get the shots, and meanwhile we loot the banks somehow and some behind their backs. Well, I doubt that happened. I have until someone can answer that question for me, I have to believe there is a virus out there. Okay, for those of you who believe in virus, because that's another group. Okay, but for those of you who believe in viruses, okay, and do you really think that all these governments in advance, before what was it, 2019 December or thereabouts, or beginning of 2020, they all decided before that, in advance, that they were all going to do this to their own populations, and they're going to create this inexistent problem, saying, hey, we got this COVID, everybody's got to get a shot, and blah, 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 and distract people's attention from the real problem, which is the economy. And meanwhile, they threw the economy, told everybody, go home, we're going to send you your paycheck, and don't bother even to come to work, because maybe there is no work, okay? And so on down the line. And so I doubt that everybody, this was premeditated. Now, there is a twist to that, and the only one that I can allow in my mind, okay, and that's that, the United States went to this town in China. What was in 2019? There was a military get-together, and according to Chinese, the Americans brought the COVID with them, and according to Americans, the COVID started in that city because the Chinese created it in a lab. Okay, so each one is pointing their fingers at each other. Great. It could have been that someone created this virus, maybe, I don't know. I don't know enough about that topic. All I can say is that's the only way I can conceive of a premeditated action, where someone created it for whatever reason, maybe for the reason I just explained, to be able to loot the banks and change the system. And they threw it out into the world, and then countries like Cuba and Iran had no choice but to accept the fact that some of their people were getting sick. And so it's not that they agreed in advance, but they took care of the problem once the problem was upon them. And that's the only scenario that I can see, other than the COVID being no conspiracy whatsoever, just something that arose out there. Okay, so those are the two possibilities. But if someone can tell me why all these governments agreed, then I'll rest better at nights. Okay, so here are my questions for all those people who want to tackle them. Okay, was the rise of women inevitable? The fact that women matched us, are us meaning men. So we have women that came up and men who came down, a little bit, and so they kind of are demanding their rights. Was that inevitable? Was giving women the vote inevitable? I mean, almost every country on the planet, in fact, I think all of them give women the vote today. I don't know if there's any exception. And 100 years ago, it wasn't like that. In fact, 100 years ago, women did not, a little more than 100 years ago, women did not have the right to vote. And so, yeah, they've come up the ranks, right? They've become our equals. Was the increase in homosexuality among humans inevitable? Was that something that people just came out of the closet, or is it something that changed in our genetic code? Okay. Was the economic expansion of the Chinese empire inevitable? And if it wasn't China, it could have been someone else, right? Was that inevitable for another empire to rise and challenge the American empire? There's always been empires that have risen and fallen, and when one fell, the other one rose, okay? And so was that inevitable? Is this like mandated by history? Is that the way Mother Nature compels man to behave? Create new empires? I mean, we have new companies. Remember, companies in the past were manufacturing companies primarily, and they've been replaced by what? By a lot of these internet companies. Facebook, Amazon. They're all internet companies. And so, yeah, one empire comes down, which is all this manufacturing stuff. Anyone who put their bets on that, and what rose were the internet empires. So again, we see that there as well. And then related to that, were the results of Calhoun's utopian experiments inevitable? Okay, and that's related to extinction. And there you see it at the bottom. That's taken from Calhoun's experiment. I think that's number 25. And he put a bunch of mice, about 4 pairs of mice in an enclosure. And he let them reproduce, and they overflowed. There were over 2,000 mice after a little while, and then the population crashed, went into extinction. He had to stop the experiment at the last moment because he just couldn't see the results, how the whole thing ended. It just was, for him, he had seen it several times. He did many experiments, and so he didn't want to see it again, so he shut it down. Okay, but it was going into extinction. They weren't reproducing anymore. Sounds like humans, but a lot of people question that. They say, no, this is a little different. Okay. Okay, so let's move on to physics, strictly physics now. We're going to do another version of how Mother Nature does opacity and transparency. I mentioned 3 ways that Mother Nature deals with opacity and transparency, the opaque and the transparent. And one of them, the way she does it, is with alignment. That's my argument, okay? I'm saying that one of the ways she does it is with alignment. And what I showed was that, we took a couple lenses. They were these polarized lenses. And if you can see there, you can see that light disappears when at the end, at the black screen there, when the lenses are perpendicular to each other. But when they're parallel, the light goes through. So it's transparent in one direction, but when the molecules are rotated, it's no longer transparent. Now it's opaque. Okay, so if you were at the other end of that laser, the laser was pointing to your eye, you would see it when the 2 lenses are parallel. But when they're perpendicular, the light does not reach your eye. Okay, and that's what I'm showing there. I'm saying that the molecules, okay, calcium carbonate, when they're rotated, they're now misaligned. Okay, and one of the ways you can do that is that way, which is the ropes that were connected from one atom to the other straight ahead are no longer, in a parallel direction to the a laser or the beam that's coming in there. Okay. The other way I suggested is that by rotating, what you're doing is twisting the rope. Okay. And by twisting it 90 degrees, okay, you're actually changing the link lengths, okay, by a certain amount, an amount enough to take it out of the visible range, okay. That's why it becomes opaque or transparent. And one fellow questioned that, okay, it's good to have people question it, says when you rotate the lens 90 degrees, the rope also rotates. Would that not then imply that if you were spinning the lens with a motor, you would rotate the rope more and more, thus changing the frequency of any light entering those molecules, okay? Is it not more likely that the turning of the lens 90 degrees would not change the link lengths because the whole electron shell, in fact, is like a slippery ball that spins to keep the ropes at the same orientation, much like a bubble? Okay? Good input. And I'm not going to give him an answer yet. I want to continue. Okay? Let me continue, and maybe we can find the answer he's looking for. Okay? One fellow says, explain transparency in materials where the atoms are not aligned, like in the water. The water is transparent whether still or in motion. You know that water molecules are constantly in motion, don't you? Do you lose transparency just for a moment when the molecules move? You say that the alignment is not the only mechanism that explains the transparency, and then you spent several minutes explaining water transparency by the alignment of water molecules. Okay, so let's address both gentlemen here, okay? Kill two birds with one stone. First of all, nowhere did I say, the first person is just suggesting, the second one is stating, oh, you said this. No, the reason he said this, mentioned that comment, is that he wasn't paying attention when I was talking. He was busy talking himself. And so, when you talk and you don't listen, well, yeah, you're not going to understand what's going on here. What's going on here is I'm not here to give you answers. Okay, I'm not here to give you answers. I'm here to provide you with the tools necessary for you to figure it out on your own. If you go back to the ancient Greece, right? You had Socrates, and allegedly he got together with his pupils, his students, and he never wrote anything. And again, it's the victors who usually write history. In this case, he wasn't a victor because he was forced to drink hemlock. But, his students wrote about him, and we can only go by what they tell us, among them Plato and Xenophon. Later on, student of Plato, Aristotle, he also mentioned them, Socrates. And the way apparently Socrates dealt with his students was when they asked the question, he would typically answer with another question. And it's a good method because it throws the ball back to the student, and the student now has to think. If you just give them the answer and say, this is the answer, so, oh, okay, I'll memorize that for the test. And so he hasn't really grasped what you were telling him because it was a freebie. So he said, oh, okay, I see what you're saying. And he didn't see anything. And so the issue here is, I'm not here to tell you how transparency and opacity is done. I'm here to give you clues of how Mother Nature does transparency here in this situation, in this situation, in this other situation. And I'm showing you that also, parallel to that you cannot explain those situations, transparency, opacity, with waves or particles, quantum. You cannot give a physical interpretation to opacity and transparency using the waves and particles of mathematical physics. That's where the problem is. And so I'm contrasting the rope model against that, and I'm showing you that under the rope, you have all these options. One of them, like I'm saying, is twisting the rope. The other one is the rope itself goes out of alignment because, you suddenly, move that thing around. And so now the light from the laser does not go through the same ropes to reach that first the second slab and then the screen. I'm just giving you clues. You're supposed to give me the answer. Okay? And nowhere did I say, hopefully I didn't say, that either air or water or glass is because of alignment. Okay? I'm giving you an example of something to keep in mind when you're looking at all these transparent media. Okay? And so people confuse that and say, oh, Bill said. No, I didn't say anything. I didn't say how, why. So far I haven't said, as far as I know, so far I haven't said why air, water, or glass are transparent. Okay? I'm giving you clues, what to reject, what to accept. Okay? So you're supposed to figure out why air, water, and glass are transparent and brick walls are not. Okay? Second issue, I said, well, one is alignment, one thing to keep in mind. I did say, by the way, yes, I did say that in the case of polarizers, it is the 90-degree turning of the molecules, okay? That I did say. It's the only one I said so far, okay? Other than that, I haven't talked about air, water, or glass. I'm not telling you why they're transparent. I'm suggesting you look at the fact that even though, like this fellow says, water moves, air moves, the question is, when you rotate water, does the molecule rotate as well, or does the water remain in the same direction with respect to the center of the earth? Gravity, in other words. That's the issue, okay? For you to ponder, do the molecules of water stand on their side, oxygen, hydrogen, oxygen, hydrogen? If they're like that, do they also stand like that? Despite that the water level, you can see that the water, when you turn that glass around, the water stands still, more or less. It moves a little bit, but water remains level with respect to the center of the earth. Gravity does play a role in water for some reason. Does it play a role inside a balloon full of air? Does the air also turn on its side, the double O oxygen or the nitrogen that's in there, whatever's in there? Does it turn on its side, or does it remain always in the same direction with respect to the center of the earth? I'm trying to give you clues to get you to think. Okay, let's see if that sinks in. Okay, we did quantity, and here we put a single sheet, and the sheet looked like this. Okay, just a little plastic. Here it is. Okay, you can see it's just a little plastic. Okay, a very thin sheet. And when I put many sheets, okay, you can see the light from the candle doesn't show through. So quantity is also important. Apparently, Mother Nature, if she has a very thin sheet of something, she may allow light to go through. But when she has many sheets of whatever, many of those, then light does not go through. So she built opacity with many transparencies. Okay? Second clue. It's a clue. Okay? Did I say, is that the reason water, air, or glass is transparent? I haven't said anything. Okay? So I haven't said that. Okay? Okay, so where do we go from here? Well, a couple people had problems with that. Okay, and let's see what they have. Here's the first one. Fellow says, of course you know that when light is equal on both sides, it appears as a mirror, but you can also see through to the other side. He's talking about, one-way mirrors. Okay, you can see yourself in a mirror, and the person on the other side can see you. And how can that possibly be? Here we have you think it's a mirror, and for the other guy, it's a glass. It's a transparent glass. He can see you, and you can't see him. Okay? And so he's saying when light is equal on both sides, it appears as a mirror, but you can also see through to the other side. Okay. Thank God someone mentioned that. We didn't know that. Okay, and here's another fella. See if I can get him here. Give me a second. And he says the same thing. He says, polarized lenses are coated. A one-way mirror works similar to polarization. A mirror has aluminum one side of the glass, and we can see through it. The one-way mirror has to have the lighting double the brightness on one side for the illusion to work. So neither of these two fellows paid any attention at all whatsoever to what I said. Okay? They think it's got to do something with lighting, and the one-way mirror has to do with lighting in the room. Okay? It has nothing to do with the question, with the issue that I addressed. So they're barking up a tree. They're beating up a scarecrow, dragging him through the mud, because they're not addressing the issue. Let's see if they can understand the issue, what the issue is. I don't think they will. They probably don't have the capacity to understand this. Okay, so let's go slowly, at least for the mentally disadvantaged people who come here. Okay, let's get rid of all the lighting. Okay, you want to put the lighting, put the lighting. I don't care. It's irrelevant to the question at hand. Okay, with the issue that I'm going to be addressing now. Okay, we have a laser pointed from one direction, and we know that the laser goes through. The light from the laser, the photons of the laser, not of the room, but of the laser. Okay, so the photons that make up that laser beam, that ray, those are going through. Okay, because I can see the laser from the other side. I can see everything in the room from the other side. But it turns out the person on this side cannot see the laser, the photons coming out of my laser that are going through, and instead of bouncing, because it's a glass again, but it's the same glass for both of us, right? Mine don't go through. Mine, I'm sorry, he can't see, the guy on the other side of the mirror, he can't see my laser, but I can see his. And the first question is the material that make up that mirror, this one-way mirror, is it the same in either direction? Has the amount of material, has the amount of molecules, atoms changed? Why am I bringing this up? I'm bringing this up because the explanation that quantum mechanics gives to this phenomenon has nothing to do with lighting in the room. Okay, let's see if you understand this. It has the quantum explanation has nothing to do with lighting in the room. It has to do with whether an electron of that material that you see there, of the glass, coated or uncoated, I don't care, whether the material absorbs a photon. It's the same material in either direction. Okay? It's got coating on one side and doesn't on the other side. I don't care. It's irrelevant. The material is the same. In other words, the material that the rays of the photons have to pass through is the same either way. Do we understand that or not? Has it sunk in? It's the same material. So the question is, why does the electron of one of those atoms that builds that glass, that coated glass, why does it accept this photon and does not allow it to go through? And why does it, in the opposite direction, accept that does not accept that photon? The photon's supposed to kick the electron to a higher energy level, right? It doesn't do that, and so it goes by and you can see it. It's the same material in either direction. So we're addressing quantum mechanics here. Forget about your lighting. It's nonsense. It has nothing to do with the question at hand. Okay? So here's what I showed. Maybe they watch it, I don't know. This is how quantum mechanics explains both, this serves for both cases, for transparency and opacity. What are we staring at here? We see a little photon. It hits the electron, which is at a lower energy level, and it knocks it into a higher energy level. We say that the electron absorbed the photon. When it does that, the photon doesn't get through. Okay? On the other hand, if the if the photon doesn't come with sufficient energy and doesn't kick it to the electron to a higher energy level, then it goes by. It zips by, and that's when you can see it. That's when the material is transparent, according to quantum mechanics. Okay? So again, if the material The only thing that blocks the rays of light in either direction, okay, if the material is the same, why would it absorb the photon in one direction and not absorb it in the other? That is the question. Okay? So don't talk about lighting, it has nothing, or coding, it has nothing to do with the question at hand. Okay, let's see if we can continue. And again, it's because these people don't listen. They're not paying attention. They just want to say what they learned in college, what they memorized in college. They say, oh, but it's got coding. Oh, but the lighting in the room. They're not listening. Okay, temperature. I said that's another factor we got to consider when we look at transparency and opacity. Okay, and what I did, I took a glass and I put a pen in there and froze it, and then I just let it outside, let it melt, the ice, and I filmed it every 10, 15, 20 minutes. And there you can see what happens suddenly, the pen comes into view. It was not visible when the ice was solid, and it's visible when the ice melted. So temperature did something. Okay, apparently temperature has some bearing on opacity. That was my argument. Okay, and you can see something similar at the bottom where you see a pot boiling. You have that water come out as steam and it's hot. And apparently the temperature did something to the water, because the water inside that pot would be transparent, but the one there with all that smoke coming out, that's not transparent. It's that foggy thing. So temperature apparently has something, okay, to do with transparency and opacity. Okay. Did I say that water is transparent because of heat? No. I'm giving you clues. All the things you got to factor when you ponder why something is opaque or transparent. That's what I'm saying. I'm giving you tools. Okay? Please understand the situation here. Okay. Okay, and here we continue. The fellow says, you better not use water becoming opaque when it freezes in the next video, because those are air bubbles reflecting and scattering. It's almost easy to make ice as clear as liquid water and not hard to find pictures of it online. Okay, so he's saying that ice and water are both completely transparent, identically transparent, and that my experiment really did not prove anything or show anything or whatever, to him at least, because he said what I did was trap bubbles. In other words, that water had more air, I guess you could say, more air than water, and that by capturing all those bubbles, that's what made the water opaque. Okay, well, it could be. I'm almost sure that's the case, but I just want to show you something, okay, for you to reach your own conclusions again. Here's different pictures of ice that, like the fellow said, you can find a lot of pictures of ice out there, and I haven't seen that they are very clear as water. The other thing I want to mention, if you look at all these pictures out there, okay, and if you Google them, you'll find that they all have to do with commercials. There are companies who are trying to sell you a machine that makes ice. And so they'll say, look, our machine makes great ice, and if you put this ice and you do it this way and this way and that way, you'll get clear ice, pure ice, and it's crystal clear. So they're giving you a sales pitch, and that's what most of these pictures are all about. They're about, selling. Have they done anything very, like a lot of people say, scientifically? In other words, did they do a controlled experiment? And the answer is probably not. Okay, they just say, look, if you boil water, get rid of the gas, the air bubbles, then you're gonna, and you freeze that, then you're gonna have a better chance of having crystal clear ice. Okay, but if you look at some of the pictures out there, the jury's still out for me. Okay, you look at clear ice, and it doesn't look so clear to me. Okay, and that's just one picture I pulled out at random. Okay, here's another one. Just want you to look at these pictures. Okay, in comparison against water, and I don't know. I still say that ice, even if you do it perfectly well, get rid of all the air bubbles, whatever, nitrogen, whatever is in there, okay? I'm not sure you're going to get it as crystal clear as water. Pure water versus pure ice. I think that ice is a tiny, itsy bitsy, more opaque than water, okay? Okay, so you don't believe me. Don't believe me. Don't accept what I just said. Let's go further. I did mention this, and that's argon is solid. It's more or less transparent. Liquid, it's also more or less transparent. In a gaseous state, the opposite, okay? In a gaseous state, heated, right, at room temperature, it's opaque. So here we have the opposite effect, okay? We went here, in the other case, we went from liquid to solid. Here we go from solid to liquid to gaseous, and it becomes opaque in that direction, okay? So my argument was what? Temperature has something to do with opacity. That was my sole argument. Did I say that water is opaque because of heat? Did I say that air is transparent because of heat? No, I'm just giving you the tools to look at all the factors that govern transparency and opacity. Okay, so let's keep the context in the right place. Okay, so again, one of the issues here is that I'm not here to give you answers. Okay, I try not to give you answers if I can help it. I'm trying to get you to think. Like Socrates, you ask a question, I'm going to try to give you clues and ask you a question. I think it's better. It's more healthy for your state of mind, okay? It makes you think. It means you understood what I'm saying. If I just give you the answers, oh, okay, Bill said this, and walk away, you never understood anything, okay? Okay, that's one of the points. The other point is that I'm trying to make is, we got to destroy quantum mechanics, the nonsense of mathematical physics, which still, 400 years later, is still doing all simulations with particles and waves. Okay, and so one fella asks, he says, light is passing through glass. He insists that light travels through. And so, yeah, that's a statement. You haven't said anything because you haven't told us what it is that is traveling through the glass. Okay, are we talking about particles? Are we talking about waves? Are we talking about ghosts? What's going through the glass? You have to identify the object. If you haven't identified the object, you cannot say travel through, passing through, goes through. You cannot use that term because you haven't identified the object yet. Okay, so you need to identify the physical object that is going through the glass. Okay, then you can say, yeah, see, I can show you a movie of how whatever, a particle goes through the glass, or how a wave goes through a glass. And then, of course, you got to identify that object. And of course, we know there's no such thing as a wave, because a wave is a bunch of vectors. Particle of quantum is a concept that's a zero-dimensional point particle, meaning it's a wave function collapse, which is a concept, and we don't move concepts in physics. So we have no particles and we have no waves. So you can't use the particle or the wave. So what is the physical object that's going through the glass, traveling through the glass, breaking through it, and it doesn't break it? You have this photon going through there, all these bullets, and they don't break the glass? Okay. And so a fellow insists, he said, wave is both a noun and a verb, light. Wave has peak and trough, width and height, width and length. We can see and touch with human perception. You can touch a wave. Wave is an object. Oh. Well, again, all we're seeing there are vectors. What's a vector? It's magnitude and direction. And what these people are saying is that we have magnitudes that are traveling. We have number 5s that are traveling, number 6s that are traveling. That's what they're saying. So no, 5s, 6s, 7s, and 8s don't travel. You have to identify the physical object that is traveling, that is waving. Okay? And they, a lot of these people say, well, we have the math. We have have the equations to show you that we've measured and we've put the observation in the form of an equation, so we describe what's happening in there. Well, can an equation tell you what physical entity, what invisible, untouchable entity is doing light, is doing gravity, is doing magnetism? You have the equation, and here's the equation, okay? You have an equation, and it shows a rabbit that is moving, okay? Well, maybe that's what your equation says, but maybe what's happening is something else. Maybe it's a snake that's twirling in place. Maybe that's what the invisible thing is. So maybe your equation is for that invisible entity is wrong in the sense that you think there's something moving from A to B, from left to right, and what's actually happening is something is twirling locally in place. In fact, that's what a wave is. Okay, so the question is, is the equation going to tell you what invisible entity you're mapping, representing with that equation? Okay, so you have to know what the object is, and for that, there is no other way. You can't go to the lab because you're not going to be able to see or touch it, because by definition, it's invisible, intangible. That's the description. Okay, so you're not going to be able to go to the lab and use your eyes or your hands to see that which is invisible or touch that is intangible. The only way is to drink a beer, go back, and and think. This is something you have to try to visualize. You visualize first, then you can apply the equation. That's the way it works in science. If you want to describe it with an equation, go ahead. But right now, what we need is a physical object. And right now, we don't have a physical object coming from the mathematical establishment. But all those people who talk about, traveling through, that's what they got to come up with. They have to come up with the object that is traveling through, going through, moving through. Okay? We want to know what is it that is moving. Okay, because for all we know, maybe all you're doing is describing the humps of a camel that are moving up and down locally. Okay, so what's the fourth one? Well, we had alignment, we have the quantity of material, right, the different layers, and we have the temperature. Okay, so we have three clues now that Mother Nature uses to govern opacity and transparency. Today, well, let's look at crystal structure. Okay, here we have transparent. Generally, we have gases or liquids. Not all of them, but a lot of them are transparent. And in general, we associate what is opaque, opacity. We usually associate that with stiff things, with rigid material. Okay, we think of a brick wall and we say, well, that's not transparent. We think of a steel beam, we say, well, that's not transparent. So if someone asks you to name things that are transparent, you would say, well, air, water, glass. You name the usual suspects. Okay, you don't mention those things which are generally solid. Okay, of course you have tables which are transparent and so on. Glass more or less looks solid, right? You can touch it; it's quite solid. But in general, we associate transparency with malleable or soft things, whereas hard things are typically opaque. Okay, and so I want to address that today and just give you this other clue, fourth clue. Okay, and here's one way of looking at it. I want to show you this. I do it with a ball and I throw it against a spring. Okay, and the spring is pushover. You can push a spring almost anywhere you want. The spring itself is malleable, it deforms. Okay, so you would think that if light behaves like that, right, the spring would pass whatever motion is given to it to whatever's behind it. It would, send that same signal behind it, meaning that maybe it's a way that Mother Nature does transparency. In other words, imagine the rope giving a signal to that spring, and the spring is such a pushover that it just gives a signal to whatever's behind it. Okay. On the other hand, if you do it with a tree, right? Well, the ball doesn't the tree doesn't really pass it on, that vibration, to whatever's behind it. Okay, it does receive a little vibration, a tiny bit, right? But the point is that it's not going to move the world behind it. And so I'm saying that maybe this transparency, opacity, has something to do with the rigidity of the molecules that form whatever body you're analyzing. Okay? But there's a problem with that. Okay, and let me show you what the problem is so that you balance that on the other side again. How about sound? You have sound, you make a noise, and it travels through the air. But it turns out that sound travels faster in liquids and even faster in solids. So you would think that if I send sound waves, meaning that I'm not sending any wave, meaning it vibrates locally, right? If I send these sound waves, just to speak like that, okay, I'm going to use that language, you would think that if a solid thing transfers that sound faster, you would think that that would be the means for transparency for light, and it would be the other way around. In other words, it would be solid things, rigid things, which would be transparent, like steel and walls, brick walls, and not air and water, because again, they're pushovers. And maybe if sound is a good analogy for light, maybe it works the other way around. Okay, so maybe that kind of balances it out. You can have arguments on both sides on that. Now, it's important to understand that sound, is built with molecules. Molecules are vibrating in situ. Okay, and I showed that the other day. Okay, and first here we see solids versus liquid and gas. You can see that sound travels faster in solids than in liquids, and liquids faster than in gases. Okay, so and it's due to the density of the molecules that build up those materials. Okay, so that's one thing to ponder. But here we see that the waves are local. In other words, when I talk, the molecule that I'm vibrating here in the air, that's not the one that reaches your ear. And even in a steel beam, if I send sound through a steel beam, the molecule that I vibrate at the beginning of the steel beam is not going all the way through the steel beam to your ear at the other end. Okay, it more or less works like this. Everything vibrates in place, and you receive the final vibration from the atoms, molecules that are close to your ear. Okay, which again vibrates the air that's close to your ear. Okay, so the issue is there's no traveling through. That's the main point. Okay, this notion of traveling through first has to die. But then the question is if sound is a good analogy for light. You have to remember Huygens, Christian Huygens, when he simulated light, he used water waves as an analogy. He said, what if we drop a stone in the water and we create these waves, and maybe light is like these water waves? Well, obviously he was wrong, but it was a good first attempt, no problem there. But it turned out that that's not the way light behaves. And so the question is, can we use sound as a simulator for light as well? And the first thing I have to point out is that in space, sound doesn't work. Okay? Now this is important for several reasons. The first one is that light does work in space. Light goes from the Andromeda galaxy through space, we'll use that, traveling through space. Somehow light reaches us from the Andromeda galaxy. So space does not seem to be an impediment for light. On the other hand, sound does not travel from one astronaut to the other through the space right here in our solar system. They're both on the moon, which is 10 to the minus 11 torr very few molecules in that at that level. And so an astronaut would not be able to talk, even if he took his thing off and he could talk, right? He would not be able to talk to the other person, or the other person would not be able to hear him, because there's nothing to carry, to use that term, the sound waves. There's no material to vibrate locally, as you just saw. Okay, light goes through, sound does not go through space. Okay? And so if that's the case, here let me show you an example here. If space is made out of particles, as quantum mechanics holds, as mathematical physics holds, they say that space itself is made out of particles. And if that's the case, then why is it that light goes through? You could say, well, yeah, because it's made out of particles. How come sound doesn't go through if those particles are there? If all of space is made out of particles, why don't they vibrate when we talk through space? Okay, we have a problem there, because they use space. They say space is made out of particles, but those particles do not carry sound. Well, why not? I mean, why don't they wave when sound goes through there? And some people say, well, Bill, you're wrong. You got it wrong. No one ever said that space is made out of particles. Okay, so let's prove them wrong. Let's prove these people wrong so that they never open their mouth again. Okay, let's show them what quantum says. Okay, because they don't know their own religion. Okay, the quantum this is the first part is from the Wikipedia. The other is from another website, but you can look it up anywhere you want. Just look up, for example, pair production, and you'll find out that yes, quantum says that space is made out of particles. The Dirac space is made out of particles. They're all saying the same thing. They've been saying it for 100 years. So if you haven't been listening, that's your problem. Okay? The quantum vacuum or quantum state is the quantum state with, or vacuum state is the quantum state with the lowest possible what? Energy, whatever energy is. What is it, a concept? Okay, you might say, well, energy is a concept. So what do they say? They say the space is made out of concepts. Quantum foam, also known as space-time foam or space-time bubble, is the quantum fluctuation of space-time. What is space-time? A concept, right? What is time? Isn't time a concept? Okay, they're talking about the fluctuation of time. It's fluctuating, it's moving, it's vibrating. Time itself. The second is moving up and down, 5 seconds. Okay, on very small scales due to quantum mechanics, matter and antimatter is constantly created and destroyed. I don't know what destroyed means, because they blend and they form what? Nothing? Two particles get together and they form nothing, and then they come out of nothing and form two particles? They're just cheating. They're saying that a black particle and a white particle form a no particle, and the no particle can separate into white and black particle. What they're really saying is, well, we don't want to call that one in the center a particle. And so they say it disappears, whatever that means. What does disappear mean? What did the particles turn into? They turned into nothing. What is nothing? Please define the word nothing. What is it, a particle? Is it a ball? Or what does nothing look like? Okay, so the issue here is these people are cheating, because they're saying we have two balls, they get together and they form a no ball. And they say a no ball, but they don't define what a no ball is. In other words, nothing. And then they say from the no ball, from nothing, suddenly two particles, two balls come out of there. It's cheating. Of course, Feynman says nobody understands quantum mechanics. How can you understand if you give me an irrational explanation and trying to get away with it? Okay? A vacuum is defined as a space with as little energy in it as possible. Always that word energy. It fills all the blanks. Despite the name, the vacuum still has what? Quantum fields. Fields. What is a field? A concept. Numbers. That's what a field is. Bunch of numbers. That's all it is. Potential at each point in space. That's a concept. According to quantum mechanics, particle pairs are constantly appearing and disappearing as a quantum foam. Okay, so is the vacuum made out of particles? Of course it is. They just don't say it that way, and that's why you missed it, but that's what they're saying. And this other side says pair production is the opposite of annihilation. So we have annihilation, two particles form, annihilate, whatever, they turn into zip. And then zip, whatever zip is, turns into two particles. Well, I have to believe that zip is a particle itself. What is zip? What is this nothing? Is it a ball? Two particles turn into one ball? What is this zip? Unless you define that, you haven't said anything. Okay? Mysteriously, particles can appear from nowhere. Yeah, that's called magic. It's not called science, it's called magic, black magic. Okay, so yeah, if first of all, quantum does say, mathematical physics does say, general relativity does say that the vacuum space is made out of particles. Space-time warpage. What is warping? A whole bunch of particles. A point at each. An event is a point in space-time. What is that point? It's a thing. That's what they insinuate. Okay, so the physical interpretation is that, yeah, space is made out of particles. Okay, until you understand that, you haven't understood anything of mathematical physics, of quantum mechanics, of general relativity. So get that through your thick skull. Space is made out of particles according to quantum mechanics, according to mathematical physics. But then, if that's the case, why does light, which is the vibration of all that ether, right? Why doesn't sound do the same thing? If space is made out of particles, why don't those particles vibrate and I can hear sound through space? See, that's when they introduce the vacuum, the space, and they say, well, there's nothing there, and that's why you need molecules in there. Why do I need molecules? Can't I do with the particles of space? That's the question. Okay, so what are the conclusions today? Well, we have 4 variables now, okay, for you to ponder, okay, when analyzing transparency and opacity under the rope model of light, okay? Alignment, quantity, temperature, and today we have molecular structure. I'm saying that if rigidity has something to do with, in general, okay, with how light is, whether the material is transparent or not, okay, opaque. And what is this whole thing all about? Well, it's got nothing to do with me saying that water is transparent because the molecules are aligned. Never said that, never will, okay? Don't ask what Bill can do for you, ask what you can do for Bill. Don't ask, tell. Your job is to tell me how, or tell yourself. You don't have to tell me necessarily. I'm not your confessor. Figure out by yourself, using these clues, why glass, water, air are transparent and a brick wall is not. I'm giving you the clues, the tools for you to figure it out. Okay? That's the context. Okay, let's move on to the questions or comments that people made. Here's one fellow, and he says, is it rational to propose a model which can only be comprehended when divided from its parts? He's talking about the rope. I'm talking about a rope between 2 atoms. It's like I chop it off there and just analyze, the 2 atoms in one rope. So he says, you're chopping that, we can understand that. But he says, gazillions of ropes are not imaginable, but a few, yes. Yeah, can you imagine gazillions of worms? I mean, if you want, I can put a gazillion more in there, it's one of those things that it's irrelevant. The fact that you cannot comprehend gazillions of atoms or even gazillions of particles of quantum mechanics. I mean, it's irrelevant. If quantum mechanics proposes, look, the entire universe is just full of particles, oh, I cannot imagine, I can't wrap my head around that. You don't have to. You don't have to with a rope. You don't have to with a particle. You don't have to with waves either. They're all over the place. Okay, all these things. So to say that you cannot imagine it, you don't have to imagine it. You just have to answer specific questions. You got to answer: how does light work? How does gravity work? How does magnetism work? For that, you don't need the gazillions of ropes and atoms and particles that are out there in the universe. Okay. We tackle one problem at a time. You're trying to say, well, I can't visualize the universe with so many planets and stars. Well, yeah, I mean, look out on the outside tonight, and you'll see a lot of stars all over the place, and you say it's unimaginable. You're visualizing it. Yeah, it is unimaginable. It's we got a lot of stars out there, and we're just a little tiny planet in the universe. Okay, it's unimaginable. Of course it is. So is God. He's unimaginable. Okay, another fellow insists. He says something about a laser. He says, one atom bad, many atoms bad. No explanation still. Pretty lame. Okay, does it matter? I was just responding to your complaint about one atom. Explain the coherence then. And all I can say to this poor fellow is that he's been beating around the bush on using 10 atoms to create a directional beam in the case of laser. And I'm saying again, these people have it wrong, because in to make a laser, to orient it, just like a horse, you have to put something to the sides of the horse so that the horse looks straight ahead, right? Otherwise, if you take that out, the horse has peripheral vision, okay? And to say, well, a horse doesn't have peripheral vision by itself. Well, yeah, because the only way you can get them to have vision towards the front is by putting these things to the side, so he won't get scared or whatever. And the laser is the same thing. And so the question here is that he phrased this question wrong. Okay, he's got an irrational question because he's trying to put a scenario where he puts maybe 10 atoms in a row and says, well, how can you get that beam to go in one direction? Okay, why doesn't it go in all directions? Doesn't an atom pump to every atom in the universe? Isn't it radial? And so again, the problem is with this question, with the way he phrased his thought experiment. And that's what he's got to work on. And until he can phrase it in a rational manner, I have nothing to answer. I'll answer the same way I did, and that's that, do you know how many atoms are in 1 centimeter cube of laser beam? Okay? And please answer that question first. You'll have gazillions of atoms there, and that'll give you a clue why your question is irrational. Okay? So please ponder that for a little while longer. That's all I can tell you right now. Okay, here's one fella says, draw the hydrogen atom for me. And another one answers, search atomic force microscopy hydrogen. You will get many articles. Images sections will show pictures of hydrogen bond. Well, the fellow didn't ask for a hydrogen bond. He asked for a hydrogen atom. And I think the question was well taken. I mean, please tell me what a hydrogen atom looks like. Draw it for me. And the other guy sidestepped the question. He says, look for a hydrogen bond. There's gazillions of pictures on it. Okay, let's look for them. Let's please them. Okay, let's see if we can find what he's talking about. And you look for this hydrogen bond, and this is what you find. You find pictures of atoms that they've done with atomic force microscopes and different kinds of powerful microscopes there. And these are the best pictures we've got today. That's the first thing I want to mention. What do you see there? Well, what you see there is bubbles. You see some round things, and we have to think of them as three-dimensional, meaning we're talking about little globes, little bubbles. We're not talking about a flat plane there. This is not the flat Earth. This is the 3D spherical Earth. Okay, and so what you're seeing there is a bunch of bubbles. Okay, that's the first thing I want to mention. And that's the best shot we have. And this is not of hydrogen. Okay, what you're seeing there, like in the first case, it's what, boron and nitrogen, which are bigger atoms than hydrogen. Okay, so you're talking about a monster atom compared to the hydrogen atom. This is a monster atom, bigger. And that's the best picture we've got of these little monsters. It's a bird's eye view. Okay? And this guy points to the hydrogen bonds, which is something, a little line that connects them. So what are we staring at? What does an atom look like? Forget about the hydrogen bond. What is the atom, which is much bigger? You can see it there. It's a little bigger than the little hydrogen bond. What does the atom look like? Any of those atoms. I'll give you nitrogen, the biggest one mentioned there so far, okay? And so the question is whether it looks like this or like that. Here we have the this and that. Here's the quantum atom, which says it's a little bead that's going around a sun. Okay, it's a little planet going around the sun. Is that what you just observed, or did you observe a membrane, a little ball? like the one we propose in under the rope model. Did you see a little bead going around here? Let me show you the picture again. Okay, here it is. Okay. Do you see a bead going around, moving around? Is that what they took a picture of? A bead going around a center? Is that what that is? Or are we staring at a globe? Are we staring at a membrane, a little balloon? Okay, so that's the question before this fellow. So if he says, look, Bill, it looks like that. Well, okay, so is that what we stared at? Okay, are we staring at a little bead going around? I've never seen that. I've never seen the p orbitals going around, or you never see that. What you see is, balloons. That's what they can take a picture of. Imagine if they took a picture of a little bead going around, we would see a nucleus of some kind and a bunch of beads going around, all these electron beads. That's what would show up, right? But that's not what we see. And what we see is a surface. Okay? That's all I can tell you. You figure it out on your own. Go look for them. Don't rely on testimony, even mine. Okay, so it says, one guy says, did you know that sometimes electrons do fall into the nucleus of an atom? It is called electron capture. Okay, don't tell me about falling into the nucleus. Tell me why it doesn't always fall, doesn't spontaneously fall, or why it doesn't leave the orbits. The electron bead goes around, and typically it doesn't fall into the nucleus. There is no constant electron capture, because that would be the end of the atom, right? No, one of the issues that Niels Bohr attacked was, why didn't the electron fall to the center of the nucleus, of the atom, to the nucleus? And his answer was that, the electron can only be found in certain orbitals. And so the question is, what keeps them there? What keeps them in those racetracks? Why doesn't it fly away spontaneously? Why doesn't it fall to the center of the atom, to the nucleus, spontaneously? So when you can answer that question, then, then maybe we can talk about it. But right now you're saying that there's an electron bead and sometimes it falls to the center of the atom. Yeah, please draw your atom before you do that, okay? I want to see your atom. Okay? Because it's easy to state, but unless you can draw and illustrate your atom, we don't know what you're talking about. And we're suspecting the worst, that you really don't have a good atom, one that you can defend. What you have is the planetary model, and you're talking about the bead falling to the center of the atom in what is called an electron capture. Yeah, easy to say, hard to do. Okay, another fellow, Gady, definition of life, independently travels against the path of least resistance. Yeah, okay. Well, independently, there's a little more than that. It's a natural object. Natural object that travels against the path of least resistance, and that's the definition of a living entity. The word is living, or alive. So that defines alive and living, and then the set of living, the set of alive entities is what we call life. Okay, so that's the way it really works. But he kind of abbreviated there. Okay, just clarifying that point. Path of least resistance, undefined. But the most sensible I can invent is direction of total push-pull. In other words, in rational physics, with no spirits or intelligence, literally nothing can be alive by this definition. Please redefine path of least resistance to prevent all life from being struck dead. Okay, here's my answer, okay? Here we have path of least resistance. This is an issue like shape for objects. We don't define shape in science because it is understood by rational human beings. The definition of ordinary speech suffices. Religious folk play devil's advocates because rigorous definitions murder their gods. Okay? The reason this fellow raises this is because, something is missing in his mind. He's saying, why don't you define path of least resistance? We don't define every term in science. We don't have to define every single term. In fact, by the way, that is not my official definition, okay, for life. That's the one I use on the internet. And the definition is in the book. You can find it there. It's the one that has fourth level motion. Okay, so you have to figure out what fourth level motion is. Anyways, the point is that path of least resistance is something that any individual understands. Okay, we don't have to go in there and say, "What did you mean by that? What did you mean by that? What did you mean by the other thing?" You know, that's people who devil's advocates, extreme devil's advocates that are uncomfortable with the definition because it destroys their gods, and of course they have no definition to propose in exchange. Okay, so that's the primary issue there. Fellow continues, he says, phytoplankton, coral larvae, dozens of species of bacteria and other organisms that are simply carried along water or air currents would be considered not living under your definition. He thinks that phytoplankton are not alive, that they have no motion of their own. That's what he thinks. My God, what can I say? Yeah, they're carried by the wind, they're carried by the water. Does that mean they have no proper motion of their own? Well, I'm not here to educate him that much. He should really take an introductory course of biology in science, you know, at the university. And he'll find out that, yeah, phytoplankton and all these bacteria and so on, they do move. Okay, they move against gravity. They also are moved by the wind. The fact that an ant, you know, I throw it in the air and the wind carries the ant. Does that mean an ant doesn't move on its own? My God. Anyways, these are the types of questions some of these people ask. Okay, here's another fellow, and don't bring natural, I think it's the same fellow, don't bring natural or artificial into it, because I'm saying it's got to be an artificial, a natural object, can't be one made by man, okay? It's easy to rockets are not alive to say, I guess, rockets are not alive despite going against gravity because they are artificial. Yeah, we separate the artificial from the ones Mother Nature made. Because we want to make sure that we consider the word living, we restrict it to those things that Mother Nature made and not those that humans made. And of course he doesn't like it because it destroys his argument. Well, how about a balloon? How about an airplane? And la la la. And when you say, well, it's got to be a natural object, you say, but you've done away with half of my proposals. Yeah, that's the point of it. The point of it is that we usually use the word life in terms of living entities, meaning those that Mother Nature created. And so people try to say, well, what about this and what about that? The devil's advocate again. He wants to introduce things that he may, especially like a computer program. He has Bugs Bunny moving. He said, well, Bugs Bunny's moving. Is he alive there in that picture? A two-dimensional Bugs Bunny? And again, we chop all that off, you know, pixels on a screen and so on. Are they alive? We chop all that off by saying natural objects. And of course, the devil's advocate gets upset at that because it destroys his argument. So he says, don't include, don't reject artificial objects. And so he mentions a case here. He says, what if, you know, we create DNA, create a monkey in the lab. Okay, that's what he's saying. So he says the following. He says, it's easy to, okay, he says, totally original DNA engineered by biologist and made into an amoeba or monkey or something. Would a monkey not be alive just because some nut cooked up his genes in a lab? So you make a monkey in the lab, you make a chimp or whatever in the lab. Is that monkey considered to be alive because it's secondary? It's not made by Mother Nature, it was made by man. That's his question. Okay, and so this is the answer. Okay, here we go. The nanobiologist did not make the monkey in the lab. Okay? Mother Nature made the monkey. Nanobiologists merely toyed with existing animals and molecules and genes and wombs and imitated Mother Nature's design. Okay? The fact that we copycatted Mother Nature doesn't mean that we created artificial things in motion. In fact, one of the arguments that I use against God is that one. You have the religious folk, and they say only a God, an intelligence, a designer, designed a watch. Right? You find a watch on the beach. You say, well, this could have been done by just come into being, from the mountain, from the center of the earth. Someone made that thing. And if you see a watch on the beach, like you go to another planet and see a watch, you say, hey, there's some intelligence here that made that watch. Okay? And so this is their argument, the watchmaker argument. Okay? And so the question here is, if you create something out there, does that make you a god also? You made a monkey. Maybe you're making a monkey out of yourself. The issue here is the following. Okay, it's that humans have never been able to create intelligence. Okay, they cannot create intelligence in the way Mother Nature created intelligence. Okay, we try to imitate the brain, and so we go to the lab. We build these AIs. Okay, artificial intelligences, we call them, and we say, oh, it's intelligent. Well, is it intelligent? What do we mean by intelligence then? We have to define that term in order to be able to talk about it sensibly, right? And right now, I'm just going to give you the quick verse. I'm saying humans were never able to create intelligence. In other words, we cannot create the intelligence that Mother Nature created, like in our brains, or even in a brain like a lion. Lion has a certain intelligence, not as good as ours. Probably better than some of these guys, but not as good as normal human beings. But humans were not able to create intelligence. Okay? We create a chip, but we have not created intelligence. And if we cannot create intelligence, and we created watches, but we have not been able to create intelligence, could there be a designer out there that created intelligence, like God? If we cannot do it, and God is essentially us, and we created him in our image, did God create intelligence? Well, we have no proof that humans can create intelligence, so why do we think that intelligence can create intelligence? Okay, we have no evidence of your argument. Okay, so anyways, the point here that I'm trying to make is that we stand by the definition of life, and we're not going to include anything made by man. Okay? Anything made by man is not living. Okay? It doesn't matter what you make, even if you make an android. Okay, and you say, oh, I made an android. Is that alive? Well, I don't know. We reject it under the definition of life because we want to restrict the definition of life to that which Mother Nature made. Now, that's up to every single person. If you have a justification for saying that an airplane is alive because it moves against the path of least resistance, it moves against gravity, well, that's up to you. You want to use it. If you have a purpose for using that, then use the word life in that way. It's up to you as the presenter to define the word life any way you want that suits your theory, okay? And if that's how you want to define it, fine, but hopefully you find some use for it. It's not a question of playing devil's advocate and saying, oh, Bill, I'm going to destroy your theory, your definition, because I'm going to include things which are man-made. Well, my argument to that is, again, we have no need for that in science. We want to restrict the word life to that which Mother Nature made. And if you have a different purpose for the word life that suits your theory, okay, because that's what it's about. The definitions are part of the hypothesis and are the foundations of your theory, then yes, go ahead and use the word life and include all artificial objects that move against gravity. No problem. What use do you have for it in your theory? That's the bottom line. Okay. Final question, issue. Fellow says Anton Petrov. He's a guy who's runs a YouTube site. More scientific proof that everything in the universe is connected. He's saying that he's been with that for like 2 years now, saying that things are connected. But the problem is that what do they connect them with? And where is he getting his information? He's getting his information from relativists. What are relativists feeding him, or what is he, siphoning from them. He's saying dark matter. He's saying dark energy. That's what connects them. That's not a connection. It's not a physical connection. He's insinuating that the universe is connected, meaning physically connected, and he doesn't realize that these people are introducing concepts, particles. Supposedly, dark matter and dark energy are just a bunch of particles that nobody can see. So how do you connect the entire universe, which is the explanation he gives? How do you connect the entire universe with particles, with discrete particles? Every particle is isolated, individually wrapped in space. So this particle is different than this one, and this one, and this one, and this one. How do you connect the universe with discrete particles, which is what these people are suggesting? The universe of mathematical physics is a particle universe. It's a particle hypothesis. Even the waves, the transverse waves, are made of particles. Okay, so all of mathematical physics is founded on the basis of particles, the particle hypothesis. And so you cannot talk about connection and just say it and say, oh yeah, we have dark matter and we have dark energy and that interconnects us. No, you cannot connect anything with little discrete particles. And so, for him to talk for 2 years and just bring the nonsense from mathematical physics and say the universe is connected. And what do you connect it with? We do it with dark matter and dark energy. What has he said? What is he talking about? How can you connect the universe with dark matter, first, that we can't see, we don't know what it looks like? Please make it visible, make it so that we can see it. What is he going to put? He's going to put a bunch of particles in there that weigh a lot, because they're looking for the particle of dark matter in the Large Hadron Collider. They're trying to create the particle called dark matter. Okay, so it is a particle that weighs tons. That's what they're referring to. So if it's a particle, how can you connect 2 galaxies with dark matter? How do you do it? Or dark energy? You want dark energy? Go ahead, use dark energy. I don't care. How do you connect all this stuff with discrete particles? So using the word connect is misleading, and it's a lie. That's not what they're talking about. They don't even realize it. They talk about connection, but there is no connection, because their world is what you see there. Mathematical physics, discrete particles. The rope model, for the first time, introduces interconnectivity. So if the universe is connected, it's got to be like that. It can't be like the one on the left. Okay? And so, so Anton Petrov can talk all he wants. He's not saying anything that mathematical physics hasn't been saying, and he doesn't even realize what he's saying. He's just regurgitating what they're feeding him. Okay, with that, we'll see you not on Wednesday. I've got a lot of work this week. I'm going to see you again next Sunday. So please forgive me, and we'll see you then.